All right, a confidence interval. What is it? It is the range of values that have a certain probability of containing the population mean. Now, if that sounds abstract, it's because it is. Let's say you're doing descriptive research and you get a sample. That sample is going to have a mean, it's going to have a standard deviation, but you're really less interested in that mean and standard deviation, and you're actually more interested in where the population mean is. However, we can never know exactly where the population mean is unless we go about measuring every single individual in the population, which is almost never practical. So we have to estimate where that population mean is. What a confidence interval tells us is where is that population mean likely to reside. And then we get a little more specific with the likely and say, okay, where is that population mean going to reside between which two values at a certain probability? So it is the range of values that contain the population mean with a given probability. All right, so let's go about calculating one such interval. Okay, probably the most common type of confidence interval you're going to run across is what's called a 95% confidence interval. Which, when we break that down, is the range of values that have a 95% chance of containing the population mean. Now, if we're going to calculate it, there's going to be some numbers that we're going to need. First off, we're going to need some sample data. So let's assume that we're working with a mean of 100, specifically a sample mean, a sample standard deviation of 15, and let's pretend we had 30 scores in our sample. Now, another piece of information we're going to need ahead of time is an alpha level. This is because in a minute we're going to have to find t-crit, and we're going to need an alpha level for that. So, where do we find that alpha level? Essentially, we've already found it. If we're using a 95% confidence interval, we're using an alpha level of 0.05. How you would derive this and know this is 100 minus 95 is 5. Or if you were talking in terms of proportions, which is the modality that an alpha level's in, 1 minus 0.95 is 0.05. So now we can go about working this out. Now, you may have seen essentially a confidence interval written out like this, where you have your sample mean plus or minus the estimated standard error times t-crit. Now, what that really is saying is you need to calculate the lower limit of your confidence interval, and to do that you need to take the mean minus the standard error of the mean times t-crit, and to get the upper, you need to add your estimated standard error plus t-crit. So, the thing we're going to need is t-crit. Now, to get t-crit, we need our alpha level. We're also going to need degrees of freedom, which this would be the same as a one-sample t-test, where the degrees of freedom is n minus 1 which would get us 30 minus 1 to get us 29. So if we do that up and look up t-crit in the table in the back of your textbook, what you'd find is 2.045 for this degrees of freedom and this alpha level. Now the alpha is always two-tailed because we're looking below and above. Two tails, two directions. All right, so now we can go about calculating this. The one thing we don't have is our estimated standard error of the mean, but we have the information we need to calculate it. So if we want our estimated standard error of the mean, it's going to be the standard deviation divided by the square root of our sample size. So 15 divided by the square root of 30. The square root of 30, if we take this apart one thing at a time, is going to be 5.48, rounding to 2 decimal places. And again, as always, it's in your best interest to not round until your final answer, but for the sake of clarity, I am rounding. So 15 divided by 5.48 gets us 2.74, rounded to 2 decimal places. So now we can come in and substitute all those values. So I'm going to do the lower, and then I'm going to do the upper, but recognize that it's kind of the same thing. So our mean is 100 minus 2.74 times our t-crit of 2.045, which is going to do this 100 minus 2.74 times 2.045, 5.6, rounding to 2 decimal places. So 100 minus 5.6 gets us 94.4 for our lower limit of our confidence interval. And for our upper, recognize that you actually already did this math right here. So you can kind of just cheat a little bit. 100 plus 5.6 gets us 105.6. So the APA style reporting for this would be, if I'm not mistaken, CI, no periods, and then in brackets you report your lower limit first, so 94.4, and then a comma to separate them, and 105.6. Now, if you were reporting this in the text of a sentence, you would set it off with either commas or parentheses, and oftentimes this is reported at the end of a one-sample t-test as a measure of effect size, which actually brings up another point about confidence intervals. You can actually do the same thing as a one-sample t-test just by looking to see if a hypothesized population mean is contained. So we can tell just by looking at this, hey, look, this would be significantly different from a population mean of 90, so to speak. But that's the basic scoop on confidence intervals. Good luck.